Hello guys, and welcome to another hackerrank video. Today I'm going to be solving picking numbers. I haven't been that active on YouTube like I said in the previous video yesterday, and one of the reasons because I'm actually busy, and like most people we want to come back home and just sleep or do something else, and that's one of the reasons why I do these easier problems. One is that they don't take too much time to solve, and two, you don't have to put in too much brain power into figuring out a good solution for the problem. One more thing, I feel like people feel that for every given problem on hackerrank you need to come up with the optimal solution first. I don't think that's the case here. I think just coming up with a good solution and then trying to come up with a more precise algorithm for it is a lot more better. Anyway, let's get started on this problem. We're given an array of integers and we're asked to find and print the maximum number of integers you can select from the array such that the absolute difference between any two of the chosen integers is less than or equal to 1. For example, if your array is A and then we're given the values for A, you can create two sub-arrays meeting the criterion. First array has the values 1, 1, 2, 2, and the second array has the value 4, 4, 5, 5, 5. The maximum length subarray has 5 elements. When you first look at this problem, you think that you have to go ahead and partition the array, but that's not the case here. That's the reason why this is actually under the easy category. Just by looking at the problem, the actual statement here where it says that any chosen integer, right, has to be less than or equal to 1 makes a difference here how we actually approach this problem. So you can see that this is an easy counting problem. Why is that? The problem is that if we went ahead and counted the values within our A array, even if it wasn't sorted, by counting it, it would actually sort the array for us. And all we have to do is pretty much look at the adjacent frequency of the values within this array to actually solve this problem. Let's say that we're at the index location 0 and the adjacent number would be index 1. So if we take index 1 minus 0, we get the minimal difference, which falls in the criteria for the statement here, because it's going to be less than or equal to 1, right? So 1 minus 0, which is going to be represented by the subscript or index, right? So the index is going to represent the actual number of the values in the A array, and then we're going to use that to actually calculate or sum it up to return the max subarray, right, that meets the criteria for the statement here, right, for this statement here. So let's get started. I've been blabbing for 3 minutes. Alright, so here's our function here. We're given some constraints here, so let me look at that. So the first line contains a single integer n, the size of the array. Alright, and AI is unspread, so we don't care about that. Let's go ahead and get started. So what we have to do is we have to count the frequencies of the values within our list here so that we can actually keep an order. And by keeping the order, we know that the adjacent number is going to be less than or equal to 1 if we take the index location, right, of the adjacent number to the right minus that to the left. All right. So what we need to do is we need to go ahead and keep an integer array for the frequency. So this is just going to go ahead and keep track of the count. So I'm going to call this one frequency. This is going to equal to new int array, and we're going to pass in 100 here because there are 100 elements maximum. Next thing we want to do is keep, we want to do the actual counting. So let's go ahead and utilize the for each loop here. Let me call this one value, and then we're going to go ahead and go through each value in the list. And next thing we want to do is actually count. So we're going to say frequency, and then we're going to use the value to represent the subscript location. So remember that when you create an array, the default values stored in that location is going to be 0. All right. So naturally you can increment that value, right, by using a subscript. All right, so it doesn't matter if you create the subscript using a for loop or you're passing the subscript as an actual integer, it's still a subscript. All right, so what we're going to do is that we're going to go ahead and count how many times we see that value within our array. The next thing that we want to do is to go ahead and get the maximum, right? The maximum sum subarray. So what we need to do for this is use the index and add that to the JSON index to the right. So if we're on the left, we're gonna add the value to the right. All right. So what we're gonna do here is create a for loop. I'm gonna say index. This ind is gonna equal to 0. So ind plus 1 should be less than a.size. The reason is because we don't want to go out of bounds, and so we need to make sure that the index, right? So because we're going to be accessing the rightmost value at any given point, we need to make sure that we don't get out of bounds here. So we're going to say ind plus plus. So what we can do here is keep another variable, and this is going to hold the longest here, the longest subarray. We can just call this one, let's just call it a sub array. It's going to equal to 0. What we can do here is let's do a sub array. It's going to equal to math.max. And you know what, let's do it the other way around. I feel like this is gonna do the assignment too much, and this might actually slow down the problem. So what we're gonna do here is keep a current longest, and this is gonna equal to the frequency. So ind plus frequency, and we're gonna do ind plus 1. All right. So what we're gonna do is we're gonna take the leftmost value plus the rightmost value, and if the current longest is greater than the max subarray, so let's just do max subarray. The max subarray, then the max subarray is going to equal to the current longest here. All right, and then all we need to do is return the longest, or the max subarray. All right. So let me go ahead and explain this a little bit, and then we're gonna go ahead and run this and see if it actually works. If it doesn't work, then I'm gonna go ahead and try to fix it. So what we're trying to do here is we want to go ahead and count how many times the value is frequent within the list that we're handed here. And by doing that, naturally we can keep a sorted order, meaning that the rightmost value is going to be adjacent to the leftmost value by 1 at any given point, which meets the criteria for this problem, that at any given point the biggest value, right, for example 2 right here minus 1 is going to give us 1, and the biggest value here 5 minus 4 is going to give us 1 at any given point. So if we had, for example, 6, it would be 5 and 6. All right, so once we have that, what we need to do is just add the two adjacent numbers, the left and the right, to figure out if that's the longest subarray created so far. If that's the longest subarray created so far, then we need to go ahead and store that in the max subarray. Once we have that, we can go ahead and return the max subarray. So let's go ahead and run the code. And you guys can see that we've actually got that right. And let's go ahead and submit for the rest of the cases. Alright guys, this will be it for this problem. I'll see you guys on the next HackerRank tutorial. Bye bye.